I always think of the Programmer's Creed, which was we do things not because they are easy, but because we thought they were going to be easy. Right. And that is every side project I've ever embarked on. Hey everyone, welcome to Book Overflow. This is the podcast for software engineers by software engineers, where every week we read one of the best books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here as always by my co-host Nathan Toups. How are you doing, Nathan?
Doing great. Hey everybody.
And you are in Barcelona. You're like an honorary European at this point.
Gosh, I am, but I'm all over the place. I know. I think this is the third podcast episode that I've been abroad.
Yeah, and what's funny, eagle-eyed viewers who are watching on YouTube are going to notice that Nathan is in Barcelona for a couple episodes in a row. That's not because he lives there now. It's just because somehow we scheduled like 4 recordings in a 24-hour period accidentally. So Nathan's coming back. Don't worry, he'll be back here in the States soon. But we're just making do with what we got right now.
Yeah.
Well, thanks so much for tuning in, everyone. Just as always, make sure if you're on YouTube, like, comment, subscribe. That really helps. We love watching those YouTube subscribers ticking up. We're close to 2,000. And so we just really want to thank everyone who's subscribed so far. If you're on your audio platform, give us a follow there. I know that differs across different platforms, but we track that as well. And make sure to share this podcast with your friends, your coworkers. Well, something we've really liked as we've been doing this podcast is it gets a very positive response when we tell other software engineers about it, whether that's in person or on Reddit or on Twitter or really any platform. We've had so many people say, wow, I can't believe that this didn't exist, or that's such a cool idea. So, we're confident that if you share it with your friends who are also software engineers or software engineering students or even product managers, anyone kind of in the field, they'll have a similar reaction. So do what you can, help to grow the podcast. We really appreciate it. And we appreciate everyone who's been tuning in. And as another note, our interview with Michael Feathers is live, the author of Working Effectively with Legacy Code. That was super, super cool. Nathan, what do you think about that interview?
Yeah. It's another physics background on the podcast, yes, which is really, really cool. It was a delightful conversation. We really explored some cool topics. I don't know. We've talked to a lot of folks who've sort of wandered in their career and then found their passion, and that's so exciting. I think that's a through line that we have with a lot of this stuff.
This podcast is just starting out. We haven't even hit 2 months yet. So this interview was a fun little milestone for the podcast because Michael Feathers is the first author we've had on who had heard of the podcast before coming on and had listened to the episodes about his book before coming on. So I had emailed him. We try to email the authors after the episodes go live and just say, we love the book. We'd love to talk to you about it. And he wrote back. He's like, yeah, this popped up in my feed this morning. So he's like, I've been listening to it. I've got a couple of things I'd like to address. And such a cool guy. And so, yeah, just really cool to be able to talk to him, not only about the book, but about our response to the book. Just a delight talking with him.
It was great.
Well, we are so excited about how the podcast is growing. We're so grateful to all of our listeners for tuning in. This has really just been such a blast. Nathan and I would probably do this even if no one was listening. It would just be a book club, not even a book club masquerading as a podcast. And we'd still have fun. But the fact that people are tuning in and there's been such a good response really just makes the whole thing even more fun. And we hope that you're having fun along for the ride. And we hope that we're serving you by being educational and hopefully a little inspirational, because we hope that everyone listening in realizes that there's more hours in a day than you might think. And there's always a little room in your day for some continuing education to improve your craft to become one of the best software engineers in the world. At least that's the mission we're on. Well, why don't we talk a bit about the book this week? This is part 2 of our discussion of web scalability for startup engineers. And this is by Artur Ejsmont. Let's do a quick author introduction on Artur Ejsmont again for anyone who didn't listen to the first episode. He is a software engineer and agile leader currently working for Yahoo in Sydney. This was at the time that this is his 2015 bio. He's been working with web applications for more than 10 years with a focus on agile, startup-like environments. Artur has also served as a university lecturer, and he actively contributes to the tech community as a technical writer, blogger, and public speaker. And keep in mind that about the author is 10 years old, so now he's got about 20 years of experience. He was a director of software engineering at TripAdvisor and now is the CIO at Matific, a math games company, as of May of this year. The little Amazon blurb about the book says, "This is an invaluable roadmap for meeting the rapid demand to deliver scalable applications in a startup environment with a focus on core concepts and best practices rather than individual languages, platforms, or technologies. Web Scalability for Startup Engineers describes how infrastructure and software architecture work together to support a scalable environment." And so, like we said, this is part 2 of 2. We read the first half of the book last week, finished up the second half of the book this week. I should point out for any listeners, if you're listening and realizing this is a part 2 of 2, by all means, you can go back and listen to part 1. But we do kind of try to structure these episodes so that you don't necessarily have to have listened to part 1 to listen to part 2. We'll just talk about the interesting concepts in part 2, and you should be able to follow along even without having heard part 1. So we encourage you to stick around if you're out on a morning run or on your commute and don't want to fiddle with your phone to change it. By all means, stick around. We do this for you so that you can enjoy the podcast in whatever format you see fit. We always like to give our general thoughts on the book, and we like to continue to give our general thoughts in our part 2 episodes about how our opinions might have changed or solidified as we've read the book. Nathan, why don't you tell me a bit about your thoughts on the second half of Web Scalability for Startup Engineers?
Yeah, while some of the specifics didn't age well, the principles are timeless. And again, I want to reiterate kind of what I mentioned last week. Technologies that are very common for startups now, like serverless, Kubernetes, these technologies are completely absent, which is fascinating. This was actually, when the book came out, was like, I think the year the Kubernetes came out as well. If it wasn't 2015, it was 2014. It would be very new, these new patterns. And this book kind of came out at this sort of the prime time of this new generation of startups that were emerging. I think that I think this section is I really liked the final chapter. I think it was my favorite out of everything. I think we're going to go into some pretty good detail in this. It really touched on things like scaling through automation, scaling yourself, scaling teams. And again, like the final 30 pages are my favorite. I think it could be its own book, honestly. Like I think it could be the framework for its own book. I also loved the references section. So the references section actually outlines a bunch of books that he thinks you should read or that he referenced in the book. I'm sure that a bunch of those are going to show up in our backlog. So that's pretty cool. Oh, one other thing I noticed that I feel like would be absolutely required for a book for startup engineering would be user journeys, wireframing, prototyping, and user testing. And these were all absent from this book as well. And I know that you couldn't cover everything, but I feel like there's such a focus on that now, right? Like there's an expectation that I understand, A/B testing or getting these things in place, or working with a product manager, this kind of stuff. That I think these are, just something else I just kind of thought of when I was putting my thoughts together. Carter, I'd love to hear your thoughts on the book.
Yeah, absolutely. I agree what you just said, that those are fundamental concepts for startup engineers. I do the focus of this book is web scalability, so I can see why that maybe didn't make it in. Like you, I would love a second edition of this book, just because the principles are solid. There's some of it that's outdated, like you said. Not a single mention of something like Kubernetes. It doesn't even ever mention React, and not that the front end framework of your choice is going to make a huge difference in terms of scalability, but it would just be cool to get another version of this that again is a little more modern. This book, it's a great overview of pretty much everything that goes into making a modern scalable web application, but it doesn't go into as much detail in any individual component that you might like. To me, this is more of a web scalability for engineers who know nothing about web scalability. And that's not a knock on the book, because that is a very, very useful book. I think I knew a decent amount about web scalability. That's where most of my work has been, is in large web apps at some fairly big companies. So I've kind of been swimming in this water for a long time. And it's also a subject I took really, really seriously, because I knew it was a huge component of systems design interviews. So this book has been great to get a more detailed understanding of all of that. but there wasn't anything in it that was particularly a revelation. Again, it was a deeper understanding. And so I think if you are someone who's pretty familiar with the basic tenets of web scaling and also maybe has really buffed up for systems design areas or things like that, they might not go into as much depth as you'd like. But if you're someone who's kind of like you can imagine a scenario where, because a lot of companies are pretty like tech agnostic, and maybe you spent a lot of time working on like an internal web application, and so that's kind of so you're familiar with web applications in general, but then you get hired to work at somewhere like DoorDash, and now all of a sudden you're still doing web programming, but you're doing it on a much bigger scale. This would be a great book to pick up and be like, okay, I'm already familiar with web programming, but what does it look like to take it from an internal application that services maybe 200 users to something that needs to service 10 million users? So yeah, I think just know what you're getting into with this book, and that's been a common theme through the podcast. Is not every book is for everyone, but every book is for someone, and I think that's where this one fits in a little. Why don't we get into our discussion? Let's talk a bit right off the bat about caching. Caching is one of the hot topics in this book, and a tool in the tool chest for making scalable applications. For any listeners who aren't familiar with what caching is the strategy of when someone requests data from your web page, or really from any application, you can kind of pre-store that data somewhere else and fetch it back quickly, rather than maybe computing and coming up with it on the fly. There's lots of different kinds of caching, which we're going to get into, but there's some caching where you can store it just directly in memory on the user's device, and so obviously memory is much quicker to access than like a disk read, and so caching is a very valuable tool there. There's also a version of caching that he talks about in the book where you might actually be storing the information on the disk, but you're kind of storing it in a frontline layer to the rest of your web server. So even though you might be doing disk reads on that particular caching layer, because it's a smaller layer and it's less computationally intensive, it still serves kind of as a form of caching. Nathan, why don't you share your thoughts about what we learned from this book about caching and just caching in general?
Well, first of all, one of my favorite quotes, and I say this all the time, is from Phil Carlton, which is, there are only two hard things in computer science: cache invalidation and naming things, and off by one errors. It's ridiculous, but it's also great. And I think it actually sums up three of the bigger problems that you run into all the time. Cache invalidation and naming things sound like they should be simple. Conceptually, they are simple, right? Caching is really just saying, if you get an answer from a server, you save that answer so that the server doesn't have to do the more expensive thing of either retrieving it from disk or doing a more complex database query. The idea is that you don't have to repeat yourself, right? In that you can take something that might be an expensive piece of work at scale, right? And that's what the whole point of this book is, that, hey, let's say you're serving 10,000 requests per second. Maybe it was a search result. Maybe 5,000 of those 10,000 requests are the same query that are coming in. What's the weather in Austin, Texas, or something, right? You can cache that result, especially if it's on some small interval. You can return that and give them a nice fast feedback. And there's a lot of ways that you can do caching, and there's a lot of ways that caching can go wrong, right? So the way that this book outlines it, and the way that I've done it with web startups that I've been in, is what they call layered caching. And this goes into a lot of detail, right? So like the best thing you can do is client-side caching. It's like caching in the browser, because it has 100% offload of work from your servers, right? If the data is stored on the computer and you've already downloaded an image and you reload the page and the image is still in your browser, you didn't have to retrieve that from your server, right? Then there's CDN caching, which is like edge caching. So that would be, we talked about CDNs in the last episode, but this is, again, on this edge network, and it adds that the the cat image or whatever is close to you, it might be close to other people that are interested. Let's say you're in New York City, it's close to other people in New York City. Then there's what they call like web layer caching. This would be caching that there's technologies like Varnish, which is it saves like HTTP requests, like HTML or and this might be that would sit between the CDN and your application. Then there's like the database and runtime caching, right? So this could be things like Redis, this could be Memcached. Maybe you've never heard of these technologies, but these are technologies that are really fast distributed database caching systems. So databases are great, but they're relatively expensive to do lookups, especially if it's a complex query. Like if you're asking it, give me your friends and your friends of friends on your new social media website. You probably want to cache that result, right? You probably want to keep that for a little while. And then finally, if it falls through all those layers, right? Client, web, all these things, if eventually it gets to the main data store, right? So that you're actually pulling it from disk, or you're pulling it from a database, or you're pulling it from maybe another third-party web query or something. And so I loved how the book structured this. I think that if you're new to caching, or if you found it cumbersome or a little overwhelming, this is a really good way to get started. I think they did a good job of like, I know a lot about caching. I spent a lot of time thinking about it. I still enjoyed the chapter. So what about you, Carter?
No, I loved it too. Caching is one of those things that I think always confuses people, or maybe is a little unintuitive when they first learn about it, especially if they're not in software engineering. Like, it is kind of crazy to tell them, like, no, when you go to youtube.com and you see the YouTube logo, you didn't get that from the internet. That you got that from the internet like a year ago. And they just downloaded it and stored it on your computer. And now when you boot up YouTube, the browser does its magic and realizes that it doesn't need to go to that URL anymore. It can just grab it straight from the browser. That's one of the strategies he gives. Is he says, when you host new media online, always do it at a new URL, because that's how the browser works. It basically says, okay, I need to go to youtube.com/logo to grab the YouTube logo. And if it says, and so if the browser tries to make that request out to youtube.com/logo, it's going to say, oh, wait, I actually have the result for that already. I'm going to use it. But then if YouTube wants to put a new logo up, and if they were just to replace it at youtube.com/logo, the browser isn't going to know that there's a new logo up there. It's going to just keep returning the cached one. Whereas instead, if you did youtube.com/logo v2 or something like that, next time you boot up YouTube, it's going to make a call out to youtube.com/logo v2. And it's going to say, wait a minute, I don't have this stored locally. Let me go grab it, and then I'll cache it here.
And then if you want to do the Galaxy Brain version, you'll use something called cache busting with content hashes. So a content hash is that you take the hash of the contents of the file and then append that, and then because of the hash that as long as it hasn't changed, the file name is the hash of its contents. So that file name is unique to that version of that file.
Interesting.
Yeah. So a lot of these like Webpack, Vite, all these other tools, like when you build your app.js, it'll be app.this like cryptographic hash.js or your style.cryptographic hash.css. And that's actually, it sent it through, one of the hashing algorithms. The output goes in there. And then, so as long as you haven't made a modification, you don't have to, send a new version of your style sheet down. Maybe that doesn't change.
Oh, that's fascinating.
Yeah, it's really, and so if you do this, then you can aggressively push those files up to like a S3, which then backs to a CDN, and you get this like, so you can put the caching time to live on this. You can set it to a year, and they actually recommend it's a convention that you set it to a 1 year TTL. That basically means forever, right? Like you're like, just if you've downloaded this and it still shows up and the file name's the same, don't download it again. And it saves a ton. And again, the book frames this really well. It really does a good job.
Well, I like caching, right? The whole point of web scalability, right, is don't overwhelm the servers, right? The servers at the end of the day are physical machines that can only handle so much throughput, right? I always love kind of we tend to think of computers as magic, but you realize at the end of the day, these are physical, I mean, often these days, light pulses, right, that are turning into, individual electrons. And at a certain point, you do just get limited by the physical amount of material that a computer can process, right? So the name of the game with web scalability is, how do I prevent overwhelm on my servers? And so in the first half of the book, we talked about, I think, a lot of like offense strategies, right? There's a lot of stuff about like, how do you make your servers stateless so that you can scale them out, right? That if you get lots and lots of requests, right, the requests have finally reached you. Now I've got to kind of play offense where I create lots and lots of copies of myself to handle this. Caching is on the other side of the fence. It's a defensive strategy. The question is, how can I limit the number of requests that are ultimately getting to me? And then that way, that's another way to kind of prevent overwhelm on your servers. When talking about web scalability, you got to think about both. How do you reduce the amount of requests getting to you? And once the requests are at you, how do you make sure you can handle it? So I think caching is such a fascinating topic because, like you were talking about, this kind of layered caching approach of, we can cache it right on the browser, right? Okay, next we can cache it at a CDN, right? And that's kind of a third-party content delivery network where a lot of like static content is there. So for example, when you go to Netflix.com and you watch the latest, I was going to say the latest House of Cards episode. I think that show ended like 4 years ago. I'm not on Netflix lately. What's new on Netflix? Tell me in the comments. When you watch the latest Stranger Things or whatever, right? You are not going to a server in Cupertino. Or no, where are they? They're Apple's Cupertino. They're somewhere. You're not going to a server in Silicon Valley at Netflix headquarters and retrieving that, because, I mean, that might be okay if you live in Southern California or Oregon or Nevada or something like that. That's not a huge distance of travel. But think about the people on the other half of the world, and that big 4K video file has to physically travel across the world. It'd be a nightmare. So that content delivery network, that's edge computing, like Nathan said, a lot of the resources, a lot of the static files like video or image or CSS files gets offloaded to the content delivery network and gets stored at a data center physically closer to the user. That's one of the tricks we've come up in this industry to make response times faster. And CDNs also implement caching in that way, where, again, let's say that again, a new episode of Stranger Things comes out, a very popular show. Everyone wants to go watch it. The CDN itself might cache that video file, because now when people are requesting it, it doesn't have to go to its data stores over and over and over again. It can just grab it from its cache. It makes it easier, and it itself is preventing overwhelm on its own servers. This is a good tip for any of you for systems design interviews. A common system design interview question is to design tiny URL, like a link shortener, right? Caching is a huge part of that, because one of the questions they'll ask is basically, okay, your site goes viral on Reddit, or some site goes viral on Reddit and it was shared via tiny URL. And now all of a sudden you have 1 million people in 10 minutes requesting this particular URL, and you've got it mapped to the actual URL in the database. But how do you prevent doing 1 million lookups in your database and crashing your system? The answer is you cache it. Right. And so that might be a way you design tiny URL. You might have a cache of 1,000 URLs, and you do like a least recently used cache where you're evicting the oldest one. And so that would let you preserve reads on your database, and and just your URL shortener will work faster and also not crash. So that's a tip for you if you ever get that question in a system design interview.
And I actually worked with this quantitative hedge fund a few years ago, and we built a service-oriented architecture. We had we had minute by minute ticker data all the way back to the year 2007. We were reconstructing these track records and doing these things. And part of the query system, we actually had to handle going from 0 to 30,000 requests per second. And so we had to scale up to this. And we had a very elegantly designed API system that had very clean URL architecture, so that we could cache very aggressively and we could cache safely, so that the programmers could still step through and do a bunch of custom queries without worrying about it. But as soon as we've as soon as any of the models, we had a bunch of models running. As soon as any of the models ever requested that, it would go into this Varnish cluster, and we'd use Varnish. That was, again, I mentioned it earlier, and it sat in front of our API server. So we had Fast API, which is like a popular popular Python
right?
API library, and then and then each of those services had their own databases that we had made, scale to the scalability that we needed. But Varnish saved our lives. I mean, we basically made like a distributed Varnish cluster that sat in Kubernetes. And that was a fun project. And a lot of it had to do with like cache invalidation, URL design. And again, it touched on everything that's in this book. I was just nodding my head with all the cool stuff that was in here.
Yeah, caching is one of those things I think that could sneak up on you if you're not super familiar with it, because in some ways it's kind of ancillary to designing the web application itself. When we think about designing a web application, you think, okay, I've got my APIs, I connect to the database, I host it online. Okay, great, someone can use it. And theoretically, if you don't have a ton of requests, you could get away without caching. But like we said, the whole point of this book is web scalability. And at a certain point, you need, you need to be thinking about, how am I protecting my servers from just receiving an avalanche of requests? One of the answers can be caching. So yeah, really, really enjoyed this section on caching. Any final thoughts on it, Nathan, before we move on?
Yeah, I think we pretty much covered it. Oh, there was one other quote that was kind of one of my favorite quotes from the book, not specifically on caching, but you might be listening to this section going, oh, well, should I spend a bunch of time building out my caching system for my web app that doesn't have a lot of users yet? The answer is no. If you want to play with caching, that's fine. But the quote is, any upfront cost, whether it's money or time, may become a waste. The higher the chance of changes, the higher the risk that that investment becomes waste. And so, if you don't have users on your app and it loads fast enough, don't spend a ton of time caching everything out the wazoo. Like, wait until you realize that your servers are stressing a little bit and you go, you know what? I heard about this cool caching thing in that podcast. I should go read about it, right? That's the time to do it. If you build the coolest caching system ever and you wasted 6 weeks when you could have spent 6 weeks building a valuable piece of software for yourself or for your customers or whatever, please do that. You can always use better caching later.
Yeah, he says later in the book something like 90% of startups that receive seed money fail. And then out of that remaining 10%, it's like 90% never get to the scale where you actually need to worry about something like this. So yeah, it's funny because we as engineers want to always build like the coolest, most complex thing you can get, but it's not, it could just be a waste of time. And I will say that's something that I really liked about the book. Even it's fun to read a whole book focused on a startup environment, because I've been at kind of big companies for most of my career. And so a lot of this is kind of, it's not an afterthought, but you just kind of assume like, oh yeah, everyone does this. But he has a lot of moments where he's like, hey, this is a great thing to do, but you should only do it once it becomes absolutely necessary. And again, caching is one of those things. He says, for all you know, you could run your whole web app off of one server and one MySQL server, and like that's all you'll ever need.
And these days, right, tools like Next.js, especially if you're running it on a hosted provider like Vercel, caching is aggressively implemented. And so if you have a trouble reasoning about, like, I know one of the criticisms is like, it's hard to reason about the caching system that's in Next. This book will actually equip you with the building blocks to understand why Next made the design decision that they made. I actually think that the caching system in Next is really well designed, but it is confusing if you're not familiar with the concepts.
Yeah, absolutely. Well, we're going to take a quick break. We'll be back with more discussion about web scalability for startup engineers. Stick around. We got lots more to talk about. And we are back. Thank you so much for tuning in. We just finished our discussion on caching. Let's talk a bit about one of the next chapters in the book, asynchronous operation and queues. We've talked a bit about queues when we did Fundamentals of Software Architecture by Mark Richards and Neil Ford. Great episodes about those, by the way. And we interviewed both Mark Richards and Neil Ford. So if you haven't checked those out, go ahead and check those out. I really like queues. I really like kind of like message-based architecture like that. I think it's super fascinating. Nathan, what were your thoughts on this section of the book?
Yeah, in the year 2024, if I was going to make a recommendation on learning about async and queues and things like this, I would actually recommend that software architecture book as the one that I would say, hey, if you could only read one book, read this one. This will give you an understanding of why this is in bigger software systems, right? If you need to really get into queues, that's a whole other topic. But I thought this book, it did a good job of framing it. Though I did find a couple of contradictions. So I wanted to bring that up. I don't know if you noticed this one. Let's see. I have a couple of quotes here. Let's see. A big part of the topics here was talking about decoupling, and we talked about this a lot in other books. And so one of the quotes was, not having to know what consumers have implemented, what technologies they use, or even if they have, or even if they're available, are signs of strong decoupling. And this is sort of a theme, and we'll talk about consumers and producers, our pub sub, these other like patterns that we'll end up bringing up. But a big part here is, can I build part of my system and have no idea what your system's going to do? And can you build your system and have no idea what my system's going to do? And we just keep putting along, doing our thing and building software for the business, right? I think that's like a big takeaway. The contradiction.
I always say,
yeah. Go ahead.
Was your contradiction about this right here?
No, go for it.
Oh, okay. Yeah. Because I love this idea of decoupling too. I think that's a great benchmark for if something is strongly decoupled, is how abstracted away is it from you. I always like to say a great example of abstraction is a car, because you don't need to know how a car works on the inside. You know, gas moves you forward, wheel turns you, brake triggers the brakes. So all of those inner workings have been abstracted away from you. And I think there's unfortunately a kind of software engineer that really prides himself on not understanding the concept of abstraction, where they think, oh, I'm just so smart, I know how to read into the source code, and if someone comes to them and says, hey, this product design is kind of hard to use, or this API doesn't make a lot of sense, they'd say, well, if you just read the code, I mean, my code is beautiful, you could check it out, and you'll know how to use it. But that kind of misses the whole point. The whole point is a good abstraction makes it unnecessary to know the implementation details. John Osterhout talks about that in his defense of, so in his book, A Philosophy of Software Design, another great book we read and another great interview we did with John Osterhout. But he talks about, he uses this as a defense of commenting, because he says a lot of software engineers will say, well, the code is self-documenting and the code will never lie to you. He says, if you have to read the code to understand what it does, then there's no abstraction. And so I think abstraction is one of those things that as you start to think about it more, you start to recognize it in everything you do. Like every kind of piece of technology you use, there's abstraction, right? When I click the on button on my iPhone and it turns on, I don't know what's going on. I don't know how that's actually turning my screen on and waking up the phone and all that. It's abstracted away from me. But our whole world is kind of built on abstractions. And again, I think it's one of those, I think people aren't thinking about it too clearly. Like I've seen some people kind of like poo-poo that idea of abstractions, because a real engineer would understand the workings of everything. And I don't agree with that school of thought.
Is that engineer writing assembly? Because otherwise,
that engineer. Did you ever have to like write assembly in school, or heaven forbid for a real project?
No, I went through a phase where I was like trying to like pep myself up to writing a game for the like on the 6502, like doing an old NES game. But I never did it because to write like the original Nintendo was all written in assembly, like all of the games were written in assembly. So, but supposedly, and this is also because I've watched Ben Eater on YouTube a good bit. He has like a whole series, like people who love assembly absolutely love the 6502 processor, because you can like reason about, like you can keep the entire instruction set in your brain, and it's not like I've heard about x86 and like the bootstrapping process, and it's like very complex, and you have to like be a super genius or keep track of a bunch of things. 6502 is like very simple, and it's like memory registries, and you push and do basic stuff. But yeah.
I had to write some assembly for an undergrad class, and Do not miss that experience. That is like move this variable into this
Yeah.
register. And it's like you got to do addition, and that's like calling, like a function onto registers, and then you store that in a third register. I mean, it was really cool to see it at that low level. But again, abstractions exist for a reason, folks. And
Yeah.
let's just write our Go and Python and Java and call it a day.
We need more Grace hoppers. That's right.
Yes.
So the contradiction that was interesting. So one quote was, "Message queues enable your application to operate in an asynchronous way, but it only adds value if your application is not built in an asynchronous way to begin with. If your development environment is like Node.js, built to be asynchronous at its core, you will not benefit from a message broker." And I was like, this doesn't sound right. And then just a few paragraphs later, it's like, even if you use Node.js, which are asynchronous by its nature, you'll still benefit from using queues. So I think he was specifically talking about message brokers, but I also have to remember Node.js was like in the midst of its hype machine in 2014, 2015, and people thought it could solve like every problem. And while Node.js is really cool, there was this really obnoxious talk about like, oh, it's non-blocking IO, and you're like, well, kinda. I mean, it's still doing operations. You just spend a lot of time going into these like callback, loop patterns. But and it was a cool paradigm. There's lots of great stuff that's come out of it. But I think this is a little bit of conflating like which programming language you use and whether or not you use queues. I actually don't think they're correlated.
Yeah. So, because what are queues great for? Queues are great for, right. They talk about that idea of blocking and non-blocking, right? Where if you want to send an email, I think this is the example he uses, right? Let's say you have an email application, you want to send an email. If the screen pauses and makes you wait and gives you a little spinning beach ball or something until the email sends, that is a synchronous operation, right? The entire thread stops until that has been completed. That's how programming and how computer applications were for a long, long time. And it's only been recently, recent the past 20 years or so, right? Where we've started exploring more and more asynchronous operations. But the idea is, if you don't want your user to have to wait and look at a loading screen, you can offload that asynchronously, right? Now, some things aren't great for asynchronous operations. Like I'm trying to think about, like a video game, for example, right? If I move my character, I need that to happen right away, right? I don't offload that to like an asynchronous queue that when it gets to it will move the character. I need that immediate feedback, right? But there are a lot of things that you can offload to a queue because it's not super important for them to ultimately work or to happen right away.
Getting back to that quantitative hedge fund, one of the things that we did is sometimes we didn't want to pummel the server with a bunch of requests. Sometimes we wanted to prepare a data set, and so maybe we would like give me all these stocks across all these dates, and then provide this big, Parquet file or some big structured columnar data set. What we could do is submit that API request, let it do its big expensive thing, block the whole time, so it's just waiting, bring the data set back, and then return it to the client. The problem is that blocks a ton of resources all the way up. And if anything in the stack gets interrupted, well, we just wasted a ton of effort. You didn't get the file that you're looking for. And so we used asynchronous patterns. And so you would put in the API request and it would immediately return a job ID. And the job ID just says, hey, like we got we're working on it. We got this thing. And then you would use the job ID and say, like, tell me the status. Like, is this data set ready? Is this data set ready? And then finally, when it was ready, it would give you a URL of where you could pull the data down. And we did a bunch of asynchronous stuff in the background, right? Like a lot of these things were decoupled systems, and it allowed it to be very resilient because if anything messed up, they could have its own retry logic. They all understood the job ID. When the job was done, the data was stored in, S3 or something. And it's a great example of like, it was a decoupled system. We weren't blocking, the person who's waiting on the data, they're not sitting there with an open connection waiting for, 2 gigs of data to come down. And this is a lot of the way that these message queues happen is like, oh, I want this thing. I want you to know that I want this thing. And then it goes, cool. Well, I'm going to let you know that I'm working on it, right? And then it's like going to go do all of its magic. Kind of like putting in an order at the kitchen, right? Like you don't say, I'd like a hamburger, and then go like stare at the chef and like watch them make a hamburger for you. You say, I want a hamburger, you pay for it, you just, wait, and then asynchronously a bag with a hamburger in it, shows up, and you're like, cool, okay, I'm out of here. And so, yeah.
We did something like this, similar to this at the cloud provider I worked at. Ironically, it wasn't an actual message queue. We just kind of, it was like kind of a hacky like DynamoDB implementation of it. But basically, what it was is people would try to create these products that they were called endpoints, right? And they kind of served as a private connection between your private subnets and then the some of the other products that the cloud provider offered, right? We want to provision this endpoint, right? But when you set up an endpoint, there's actually a lot of things that our service had to do to ultimately get that endpoint living in your subnet and hooking up the connection and all that, right? It was a process that like theoretically could take, like as little as a minute, but sometimes 10 minutes. I think like 10 minutes was roughly our SLA, right? But again, in an asynchronous world, that would be, your screen would just be loading and loading and loading and loading and loading until that this endpoint was created. Obviously, that's a terrible user experience. So what do we do instead? We would immediately kind of create the skeleton, like the bare bones for this endpoint, and then return it with a pending status and say, okay, your endpoint is on its way to being created. It's not ready to process traffic yet. And then that was that setting up of the bare bones skeleton, that was all a synchronous operation. And then it got farmed out to our asynchronous workers, which was basically just like a loop that was running constantly. Again, in a perfect world, it probably should have been like an actual message queue that could just pop off the top and process the endpoints as they came along. What this one actually did was it was basically a loop that was running continuously, that was doing a query in the DynamoDB databases for all endpoints that were listed as pending, and then it was pulling them out and then setting them up, everything. And then when it was done, it would just mark them as completed, and then it would pop up as ready for the users. But message queues are so important and asynchronous operations for scalability, or from a scalability standpoint, because they offload resources from the server itself, right? If we're talking about it right now from a user perspective and a user experience perspective, where you think, I don't want my computer to freeze up for 2 minutes while it synchronously processes. But think about the other users that are trying to access your server, right? If the entire thread is blocking as it tries to return this 2 gigabyte file to the user, or set up these connections for an endpoint or something like that, then no one else is able to make requests to it right now. Instead, if your server kind of just serves as like your example, Nathan, like the kitchen, like this is the kitchen window or the cashier, right? That's kind of what you should think of your server as. They just accept the requests, and anything very minor they can get done themselves, much like a cashier, right? They can probably fill up your drink for you and hand it to you. That's a very quick operation that they can give to you. And in this metaphor, that would be like in this endpoint product I'd work on, setting up that basic skeleton that can be handled very quickly and synchronously. But the larger tasks, like the cooking of the actual burger, or the downloading of the file, or the setting up the network connections, that gets farmed out to an asynchronous worker. And so you get this nice like twofold benefit of it's a better user experience, and you keep your servers from being over. Well, Nathan, do we have any other thoughts about queues and async processing before moving on?
Yeah, no, the last little piece, I did like that they had a section on anti-patterns, and we don't have to get too deep into it, but I always like anti-patterns because they kind of give that counterfactual. So the four that they outlined were treating the message queue as a TCP socket. And this is funny because it's basically saying like you're waiting for this call and response, and then all of a sudden you made a coupled system again, and you're basically creating treating message queues as a database, which is that, do you want to query across all of your messages? Are you going to go do lookups and delete and updates? Like you shouldn't. You should write it once and send it out, and not worry about it anymore. Let it be. Coupling producers and consumers, which again, we didn't get too much into this, but this idea is that in a queuing system, right, a producer is one who produces messages. You just send a message out to the queuing system, and you don't care about anything. You send it out and you forget about it. Like that's in most queuing systems. You don't, not all of them, but most of them, you're just sending out messages to maybe all these different topics or channels or whatever. And then a consumer is someone who's just like, hey, I want to consume from this, right? I'm going to pull this off. And some systems you confirm that you successfully processed it. But yeah, so don't couple those together, meaning that the producer shouldn't care about the consumer doing its job and the consumer shouldn't care about the producer doing its job. And then the last one was lack of poison message handling. And this was an interesting way of framing it. I've always just known that you should use a dead letter queue, right? Like that's the thing. And I guess a dead letter queue is one I learned early on in my startup world, which is that we had a queuing system and we didn't have a dead letter queue. And then every once in a while, the queue would just kind of barf a little bit. A dead letter queue is a place for you to deliver messages that couldn't be processed. Sometimes this is because the message itself is malformed, which could totally happen. Sometimes it's the consumer, it has a bug and it doesn't know how to process a message that was properly formed, but you didn't know how to process it. Or there might have been some other problem, but it's a place for you to literally, the letter couldn't be delivered. So it's a special like little mailbox for all these. It's a queue of messages that couldn't work in the queue. And there's all these cool things that you can do with it. But yes, poorly designed systems won't have this. And so, yeah, anyway.
I love how he summarizes an anti-pattern. He says, engineers tend to think alike and they often create similar solutions to similar problems. When the solution proves to be successful over and over again, we call it a pattern. But when the solution is repeatedly difficult to maintain or extend, we call it an anti-pattern. And he goes on to say, a typical anti-pattern is a solution that seems like a good idea at first, but the longer you use it, the more issues you discover with it. By getting familiar with anti-patterns, you should be able to easily avoid them in the future. It's like getting a vaccination against a common design bug. And you can see how that might happen at the beginning. You could imagine a situation where you have a message queue. Maybe there's a particular type of data that's stored in the message queue and it's only stored in the message queue. But then you're finding that in other parts of the system, you need to be doing lookups for this particular data. And you might think, oh gosh, we're gonna have to design a database. But then the clever solution is someone comes along and says, wait a minute, the data's already in the message queue. We can just get it out of the message queue. And you think, oh, that's so great. Look, we're gonna save resources. It's less work. But you've kind of invalidated the point of the queue, right? The queue is kind of a fire and forget it. So you don't really need to worry about maintaining the queue. You just pop messages off the top one at a time. But the moment you start using it as a database, you've just created a worse database.
Right.
So I'm always on the lookout for anti-patterns. And yeah, it's surprising how often you'll see them in the wild and how often you'll sometimes be guilty of implementing them in the wild.
And I'll tell you, we'll learn an anti-pattern, right? Something that was even best practices at some point will become an anti-pattern once new technology comes out, right? Especially because you try to use an old trick with a new technology, and then it becomes an anti-pattern. So it's always important to pay attention to the technology that you're using and maybe making sure that you don't have the golden hammer problem, which is that you have this golden hammer and everything becomes a nail. Queues are their own thing. You should read about it. And the other thing I liked about this book is it would go kind of broad level talk on a topic and then be like, you should read more about this. This is a great resource, right? And I really like that about this book.
Absolutely. Well, we're going to take a quick break. We'll be back with more discussion about web scalability for startup engineers right after this break. And we are back. Thank you so much for listening. Just want to give a quick shout out to, there's a whole great chapter on NoSQL, on data, on indexing. We learned a ton from it. It's honestly so good, and there's so much great stuff in there. It wouldn't do it justice to kind of talk about it in a 15-minute section of this podcast. And there are so many great resources about NoSQL and how it works and all of its advantages and kind of being, for all intents and purposes, infinitely scalable in a horizontal fashion. And the origins of NoSQL are super fascinating too, because it's kind of a response to the new big data age. Really, really interesting stuff there. We're making a purposeful decision not to talk about it right now because there are just so many great NoSQL resources. Go find some of them. Leave them in the comments if you find anything particularly interesting. We'd love to check it out ourselves. We're going to move on to kind of the final section of the book, which is more career focused. It talks about teams, it talks about yourself, it talks about automation, we talk about burnout, things like that. So Nathan, you kind of led this whole discussion with saying that this was one of your favorite chapters in the book. Why don't you talk a bit about what you really liked about this chapter?
Yeah, absolutely. So this final chapter, it starts with automation, and the quote is actually, "If you want something to happen, ask. If you want something to happen often, automate it." So it kicks off this whole section and kind of talks about, a little bit on test automation, CI/CD, observability. So this would be things like making sure that you're, putting your logs in a central spot, making sure that you're gathering up metrics and data like that. Um, but it goes right into also like how to scale yourself in a startup and also how to scale your team. And I thought this was just a really thoughtful section. And I wish honestly that there was more of this in the book.
It'd be cool to see Artur Ejsmont do another book that's a little almost like Clean Coder by Robert Martin. It's kind of career focused. You get the impression he has lots of great advice because this chapter, it's only like 30 pages, but there is so much great stuff in it. I really like the stuff about automation too, about continuous integration, continuous delivery. If you're not familiar with continuous integration, continuous delivery, CI/CD, it's basically the process of if you're a newer engineer coming up and if you've worked at a lot of more modern companies, you don't even really know what this is. It's just kind of the world in which you operate. But it's the idea that your releases, when you release a new feature, should be relatively seamless. There's not a lot of manual work required to get the software from your computer into the hands of the user. That's a relatively recent invention. Again, relatively being like the last 20 years or so. For a long time, releases only happened every couple of months, right? Or they would have to mail a physical disk to you to update your system.
Right.
And so there would be a lot of manual labor into releasing software. Some places still do it. Once again, the awful little startup I worked at gets a shout out for our release process being a huge nightmare that many of us wanted to change and volunteered to step up and figure it out. And they would not change it because the people in charge of the release process were contractors who got paid overtime and were hourly. And so if the release process was a big nightmare, they just made a bunch of money. That was a really messed up situation. That was actually
a bad alignment of incentives,
yes,
right?
that was part of the reason I quit. That was a lot of fun. Anyhow, but I'm such a big fan. A lot of this plays into a principle I really believe in, which is the blameless postmortem. Which is anytime a big incident happens, right? Most incidents are always like the catalyst for them is someone pushes some bad code, right? CrowdStrike, that huge outage that just happened, right? At the end of the day, that was a single engineer who pushed that code. But I think at every good, healthy company, whenever something crazy like that happens, the first question you ask is, why were they even allowed to do that?
Right. How did we as an organization fail, right? And that's really
exactly
what the blameless postmortem is saying. Something in our processes failed. Sure, an individual might have been responsible for this, this, and that, but as an organization, we let them fail, and or maybe we didn't. Maybe the person was being malicious. Well, we maybe need to think about malicious actors even within our own, within the gates of the castle. So postmortem, I'm a huge fan of blameless postmortem as well. That's really, really kind of cool. And this ties in, like, you may have heard MTTR, right? Mean time to recovery. This is a way that SREs measure themselves. And I think this ties really well with the blameless postmortem. Because this is a way you measure yourself. You say, how long did it take me to discover that there was a problem? How long did it take me to respond to the problem? How long did it take me to investigate and come up with a conclusion? And then how long did it take me to fix the problem? In the full time from when it happened to when it gets fixed is your MTTR. And this is a cornerstone of SRE, or site reliability engineering.
Absolutely. Thinking about that, and I've been on a number of calls where, again, this cloud provider I worked at, that was a huge part of the job was like incident response, being on call, and you learn a lot about like how do you bring a system that's broken back up to healthy. Exhilarating in a lot of ways and absolutely terrifying in a lot of other ways. I just think it's it's the sign of a good, healthy work culture when these kinds of issues happen and you feel, again, like it's an organizational failure, right? If your mean time to recovery is too long, most of the time that's not because you're like an idiot who can't figure out how it works, right? We had a particular incident at this cloud provider where it was just like the perfect storm of like some uh really bizarre like credential rotation issue happened that took down like the entire service in one of the data centers. You're talking about 100% failure, and it happened on the 4th of July weekend. And so not only was everyone out of the office because it was a weekend, but a lot of people were like traveling, and so they weren't even available. And so it just got escalated and escalated and escalated up until we finally got like a principal engineer on the line, and they were able to ultimately solve it. But this poor frontline engineer, and we had a really long MTTR on this. I think it was like 6 hours or so. This poor engineer who just drew the short straw. He just his confidence was really, really shaken, and I made sure to reach out to him and said, like, I just want to let you know, all of us would have struggled with that. Like, you were just the guy who happened to be on call when the other shoe dropped, but I don't think anyone would have been able to solve that one quickly. And he was really gracious about it and was thankful because it had shook his confidence.
This is a good segue into the section about burnout.
Yeah.
So
that engineer was burned out.
Burnout is your arch enemy when working for a startup, as it sneaks up on you slowly, and by the time it hits you, you're completely blind to it, making you fall even deeper into its grip. And gosh, this one is absolutely true. Early into my startup career, I was completely consumed by burnout, and it's not fun. It makes everything way more difficult. Do you have any burnout experiences?
Yeah, I was thinking about that going into this. I've been fortunate to work at mostly good places with a good development workload, and even like that awful little startup I worked at. I was fortunate, folks. I worked at this awful little startup during like the peak COVID hiring, and so like when I left, I sent out like 2 resumes and got an offer that was like a 40% raise.
All
right?
the new
Like that
grads
doesn't
right now are like, I hate this guy.
I'm sorry, new grads. People ask, they're like, I always, because people come to me, they'll be like, well, Carter, you have a business management degree. You weren't in software. You don't have a computer science degree, but you still got a job. And so, I've got a buddy who he's a mechanic and he wants to pivot into software just like you did. Like, how does he do it? I'm like, I don't know, graduate much earlier, graduate when the hiring, when hiring was hotter. It's it's not, I don't know. A lot of it isn't replicable. Anyhow, all that to say that, so I had the good fortune of when I could sense that I was going to get burned out, I said, I'm not putting up with this. You kidding me? And I left. I did work at this cloud provider for a while, and for a variety of reasons had to stay there longer than I would have liked. And then just how the handoff worked, I wound up leaving that job on a Friday and then starting my new current one the next Monday. And
Oh, wow.
I had some I had some residual burnout, and even like that the first couple months at my new job, I could tell I was like, I didn't take enough time off. I should have taken like 2 or 3 weeks at least off.
Yeah, I've made that
that's something he recommends in the book. He's like, in a lot of ways, that's the only solution to burnout is take some time off. He recommends a 6-week holiday if you can swing it. I don't know. What about you, Nathan? How do you deal with burnout, or how have you dealt with burnout?
Yeah, so I mean, one of the things I did is move to Costa Rica for 3 years. So,
oh wow,
I was the CTO at an early stage startup. We got Series A funding, and the culture shifted a bunch. And the culture wasn't deliberately, like, I've been in startups where the culture is deliberately part of the way that we built the company. And in this one, it wasn't. And I'm not, years later, I'm not trying to blame anyone. The culture shifted in a direction that wasn't for me. That's really what it was. I talked to our CEO about it, and it was very cordial, but it just was not the right spot. And I needed to like do some soul searching. I actually, when I realized I needed to step down as CTO, after being there a couple years, I was in Marfa, Texas, which is like this like place out in West Texas, kind of weird. kind of fun place. And I was like, talked to my wife about it, and we were just like, hey, what if we go somewhere? We were going to do like the travel trailer thing and like go like just live in a travel trailer, do that van life thing. This is 2017. This is before it became like an Instagram or TikTok meme. But then we were like, we like Costa Rica. What if we go down there? And I went back to consulting, and so I didn't like fully take time off, but I wouldn't allow myself to work more than 32 hours a week. And actually, I did 24 hours a week for a while, and just kind of like recharged. And about a year and a half into being down there, it just like completely changed my prospect on things. Like I had a lot more confidence again. Not this, and I didn't stop working, but I definitely like didn't do the like grind culture hustle thing, right? Like I was like a workaholic, early stage startup CTO, and it was just a lot of pressure. And I had a new kid, so it was like I think to both of those, it was a lot of stress, and it consumed me. It went from a dream setup to being something that was everything was harder, right? Everything got harder because you just kind of feel defeated at the end of the day. And even though I'm really, really proud of the team we built, I'm really proud of the stuff that was there. My approach to it and how I handled scaling and growing and getting funding, it took a lot. So yeah, getting very vulnerable in Book Overflow now.
It's funny. I don't remember if I mentioned this in the podcast or if I just mentioned it to you in like a text message or something. I have almost like the opposite problem, because I think there's definitely a point where I'm not like the kind of guy like some people are like a dog with a bone, and they get the bone in the mouth and like you can't rip it out from them. Even if it's like bad for them, they won't quit their job or they won't change things. They kind of get stubborn and set in their ways. I'm pretty open to evaluation and to realizing, this isn't working. Maybe we should do something else. But I have kind of the opposite problem where I've got a lot on my plate. For anyone who's kind of been following on the podcast, obviously we have this podcast. I've got a full-time job. I have 4 kids myself. I'm working my way through a master's degree, right? And so I have all these kind of things, and like I can feel myself like approaching burnout. But a lot of burnout gets triggered when you finally realize, like, you know what, the juice isn't worth the squeeze, or this isn't how I want to spend my life. I have like the opposite problem where I keep doing these things and they all keep paying off. Right. Like, I've switched jobs more than I would like. And so I've interviewed way too many times, but I keep getting raises and promotions. Right. Or like, this master's degree, which is a lot of work, but that was really pivotal in landing this most recent job I had. This whole podcast, really, which is also a lot of work, but we keep learning a ton and we keep meeting really cool and interesting people. And we've had great audience reception. And so it's like, I kind of keep thinking like, I'm busy, I got to take something off my plate, but then I can't look at anything and be like, this is the thing I should get rid of, because it's just all, I don't know. Things are going well right now. And it's hard to know when to stop.
I've been in that. I mean, I ran my own consulting company for 10 years and I was busy and I did all kinds of stuff. Spoke at conferences, never felt burned out doing any of that. When burnout happens, it tricks you, because you're the frog in the boiling water, and you're like the "this is fine" dog. Like, you're like sitting there, and then you look around and you're like, this whole place is on fire. Like, it's not okay. And it takes a while. And again, it's not in the blameless postmortem fashion, right? It's a bunch of situation stuff. And it's not that you're a bad person. It's not that they're bad people. I might have been angry or a little upset about that stuff for a while. Now I just look back and go, you know what? I'm not the same person that I was then. Or, I didn't know how to set boundaries. A lot of it is not setting boundaries properly. And so you can be really busy and do all kinds of crazy stuff. If you set boundaries properly, if you're getting energized, even if you're working crazy hours, you're not going to burn out, right? Like that's a different thing. But yeah.
We always say about this podcast that we'll know it's done when we don't have fun recording the episodes, because we'll be honest, listeners. I mean, sometimes, like with this book in particular, I was feverishly reading like 100 pages of it like a night before we recorded. I just got behind on my reading schedule. And so I was reading a lot, and like, that's not exactly how I want to spend my night, especially because I just downloaded a Pokemon randomizer tool, and I got a randomized version of Emerald, and it's been awesome. And so I'm like, that's what I want to be doing, spending my time. But instead, I'm reading this book, and yeah, I'm a little like, is this how I want to be spending my night? But then we come and do these recordings, and these always give me a ton of energy. Like this, it's so much fun talking about these books, and it's even more fun getting to interview some of the authors. And we actually have some interviews coming up. Stay tuned with some interesting people in the industry who aren't necessarily authors. Yeah, and so I like that distinction, like you're saying, that you got to find what are those things that are giving you energy, and those might be work or work adjacent, and that's great. I think sometimes when you think of burnout, you think I got to go lounge on a beach in Hawaii for 3 weeks, but not everyone can do that for a variety of reasons. So what else can you kind of find in your life that energizes you?
Yeah, is I think being mindful and really listening to yourself. If you have significant others in your life, friends and family, a spouse, you know, just being vulnerable and talking to them. If you don't, like, therapy is also very effective. In the book, though, I think it actually, one of the things that you can do if you feel like you're getting too close is understanding how to reduce scope, right? Understand how to say no. Because one of the reasons that you are getting burned out is that you're spinning too many plates, you're spread too thin, you're interacting with so many things that you're not able to accomplish anything. And so you feel like you look at the end of the day and you go, what did I get done today? Like, what did I even do? What am I doing here? And if that stuff's happening, you might need to work on your skills on renegotiating. And they actually talk about this. I actually loved this section as well. The first one is negotiate with your stakeholders to reduce the scope of new features to 80%, or to delay the most expensive or difficult parts. This book goes on a lot about the 80-20 principle, which is Pareto's law. It's a rule of thumb. It doesn't really mean 80% in 20% of everything, but it's this idea that a disproportionately large amount of something represents a disproportionately small, or that a disproportionately small amount of something has a disproportionately large amount of gain.
Yeah, 20% of the bugs cause 80% of the problems. 20% of the features generate 80% of the revenue.
Right. And so, he goes into that. He says, keep functionality minimalistic and as simple as long as possible, right? So don't over optimize early because it's just more stuff to do. Make sure that you implement only the code that's absolutely necessary without adding nice to have parameters. He doesn't mention it in the book. There's a term for this called YAGNI, or you ain't gonna need it. and it's, which is great, right? It's a really good, I use this sometimes when I'm looking at engineering PRs, or hopefully we're going to get that far. Hopefully we're in the design phase and I'm like, okay, I see what you're doing here. Let's do this placeholder, but let's just implement this one method. Let's not implement, the 3 that you think would also be useful. Let's see. Make sure to, strive for 85% to 90% code coverage instead of going for 100. I thought of you when we were talking about this, because I think we've had the similar idea that there's the diminishing returns, and it's true.
I'm such a diminishing returns guy. I'm like, the juice ain't worth the squeeze, folks.
Yeah. Well, and it's true, and it is. I mean, like, the effort actually becomes exponential, right? So it's one of those things where it's 80% of the effort is to go into that last 5% of code coverage, right? Like, you really don't want to do that. It's probably not valuable to the business unless you actually look at it and go, ooh, that's a juicy edge case. Like, or it might actually get to a bigger thing where you're like, I actually can't reach this if statement in this function. Then you're probably like, it probably shouldn't be there. Like, if you can't figure out a way to get to it, if there's literally no way for that code path to happen, these are the kind of things that otherwise you're going to write these like very contrived tests for something that, is silly. When creating documentation, focus on critical information in the high level picture rather than documenting everything imaginable. I think if you use that in combination with the philosophy of software design, then you actually would get a very balanced way of writing documentation and writing comments. Is that, like, take this, like, don't try to cover absolutely everything, and make sure it gives you this overview or the philosophy or the, the general utilization. I think that, kind of mix those two ideas together. I like this one. don't fix it if it ain't broke. This seems to kind of go in the face of some of the refactoring stuff we've read. But I actually think for startups, this is really good advice. When I used to work at a computer repair shop, we called it "Don't disturb the dust." So the idea was that your people used to bring in their boxy PCs, and we would open it up, and we were actually told not to clean all the dust out from the bottom of it. And the reason was, a lot of times it was static. A lot of times it was metallic dust, and it actually could cause capacitors or resistors on the circuit boards to, And so you actually could have broken the customer's desktop computer on accident, thinking you're doing a nice thing, like thinking you're going to spray out the dust from inside of it. And so we said, don't disturb the dust. So same thing. The customer didn't bring it in for you to clean out the dust in the bottom of their thing. Fix their failing hard drive and call it a day. Always try to distinguish whether a task at hand belongs to the I have to do it or I want to do it category. And gosh, I am. It says the second one is a source of huge amount of extra work, and this is true. I have to be honest with myself. Sometimes I will not distinguish those properly, and so I have to police myself and be like, do I really have to do this, or do I want to do this? And so, yeah.
I always think of the programmer's creed, which was we do things not because they are easy, but because we thought they were going to be easy. Right. And that is every side project I've ever embarked on. My goodness, The other day I was just trying to set up if you follow the Book Overflow pod Twitter account, we tend to post quotes from the books with links to the episode discussions, right? That is not automated. That is me. Just whenever I remember during the day, I copy it and post it. And I was trying so hard to preload the quotes onto a Lambda that runs 3 times a day. And then I send the Twitter API. Twitter API is garbage, folks. I pay to send larger than 280 character tweets, but you can't do that over the API, right? And so then I was trying, so I was okay, I'll just move into an Apple Notes folder. And then just whenever I get the chance, I'll just kind of use the share button and send it to Twitter. One, the share button doesn't work because it doesn't work if it's over 280 characters because again, their Twitter API is broken. I have a lot of thoughts on Elon Musk Twitter. And anyhow, so there's that. But then I was okay, well, all right, I can't do it that way, but I'll at least still get them in the notes folder. And I'm going to write an Apple script that will take this HTML, or first I take the HTML file that my Kindle annotations give me. I turn that into JSON. I feed that into the Apple scripts, right? And do that. That didn't freaking work either, right? And so I spent 3 hours trying to do this thing before ultimately just writing a script that takes the JSON and turns it into the tweets that are broken up by 6 lines of white space, and I spend about 5 minutes copying and pasting them into their own individual notes. All of that to say, yeah, that was a big I want to do it task, and it took up way too much of my time and ultimately yielded no benefit to the podcast or to me personally. So take it from me. Don't try to do any of that, folks.
And the final piece of advice was don't scale or optimize until you absolutely have to, right? Which is very funny from a book about web scalability. I think this is sage wisdom, though, which is, again, it's the premature optimization, conundrum, which is you're going to waste a lot of time and energy. That's the constrained resource you have, right? A lot of times these startups, it's time to market. How quickly can you move? And honestly, it's your advantage, right? If you're competing against a big company, they can't move fast. This is the David and Goliath thing, right? Goliath, if David was close enough for Goliath to touch him, he would have crushed his skull in a heartbeat. But David had an advantage. He could move quickly, and he was very talented with the sling. And so, it's the whole point of being in a startup, is that you have a slightly different perspective on the world. You've got grit, and you can move fast. And with those things, that you can solve some very interesting types of problems. And if you slow yourself down, all you're doing is making the bigger adversary more competitive, and you don't want to do that.
If you ever get the chance to work for a big tech company in particular, it's fascinating how much they talk about agility within the company. They know that this is, if they're going to die, that is how they will die, by not being quick enough to adapt to changing market needs. And so it's a huge priority for them because they know how valuable a resource is. And so if you're a startup, and if you work at a startup, and you might, if you've picked up and read this book, that is your number one weapon against the established competition, is agility. And so I really like that about this book too, is he has all of these different strategies, but there's always like a caveat of saying, like, don't implement this unless you absolutely have to, right? The number one most important thing is getting your product into the hands of consumers. We'll leave off with just, before we give our kind of final thoughts on the book, myself as the self-branded anti-engineer who will go to any lengths not to build something. Artur Ejsmont agrees. He says, engineers love to build software. This love for building new things makes us biased towards developing rather than reusing. Developing things like monitoring services, analytics, and alerting platforms, frameworks, or even data stores is just another form of reinventing the wheel. Before you jump into implementation, you should always check what can be used for free and what can be bought. Now, I know obviously financial constraints happen, and sometimes you have to kind of make your own homegrown solution. I get it. In my perfect software company, we would host everything on AWS. We would have Splunk. We would have Datadog. We'd have PagerDuty. We would just pay for all of these individual tools. I'm a big believer in that idea of competitive advantage, and that you're not going to create a better product. You're not going to create a better log monitor, a log searching tool than Splunk. This is their only job, is to make log searching tools. And so again, sometimes financial constraints happen, and you just say, hey, you know what? We're big enough and we have a big enough scale that we could dedicate a team of engineers to create kind of a half-baked version of this. It'll be enough for our needs and we'll save a lot of money. I get it. It's a business. You just got to be honest with yourself. You're going to create a half-baked version at best of one of the customized tools.
Somebody brought it up to me a while back, and I'm the same one. We call it, a lot of times I'll call it build versus buy, and I'm very much on the buy side if you can. If you went to an investor with a pitch deck and showed them your stack and you custom built something, would the investor be impressed with that thing? Is it a core part market differentiator of what makes your business happen? And if it's not, they won't be impressed, and it will distract you. It'll distract them. It's not something that's going to give them a return on investment. So it really is a treacherous thing, unless you really have, again, some compelling need, or it happens to be that you hired a person who's built some custom software and you just got that software from day one, and you're willing to take that, that on, because maybe it was the maintainer of some popular open source thing. And so it kind of happens to be that it's in-house, but it's also a big popular thing. It's the one rare exception. Don't build your own queuing system. Don't build your own database. Don't do these things. These are solved problems by much smarter people that have done this already.
And again, if you're a startup, you want to move, you need to move quickly, and you often have a much smaller team, right? And so again, I get that there are resource constraints, but...
And I should say, if you're a database startup, please build your own database. Yeah. That's a great idea.
Well, like this big cloud provider I worked at had a lot of kind of custom internal tooling too. Again, from a developer's perspective, I hated it. I would much rather learn something like Splunk, which can then transfer to the next job. But I saw their perspective where they basically said, listen, we have so much data coming through, and we have so many engineers that all of these licenses and all of our usage would be so expensive that for us, it actually is a lot easier to just dedicate a team to build a product that isn't as good, but will at least work, right? And so I totally get from like a big enterprise perspective why that might happen. Again, as a developer, I hate it. I'd still rather use the tried and tested enterprise products. But just as a startup, again, like your time is valuable and engineers are expensive, right? And so the odds that you're going to get a better return on investment building your own custom log searching software as opposed to just using something like Splunk or Cloud Logs on AWS, those odds are very, very low. So in this book in particular, Artur Ejsmont he really advocates just buying things off the shelf, but that might change if you're all of a sudden running one of the biggest companies in the world.
The cool thing though is that there's also this whole new breed of company. Like we looked at Sumo Logic, we looked at Splunk, we looked at a bunch of these, and they're very expensive for larger log volumes, especially if you're like a smaller group. There's these other like new companies like CoreLogix that because of like they use Kafka streams and they do a bunch of like cool transformations, and they use S3 as their ultimate storage for it.
Oh, interesting.
It's like way cheaper. And yet you still get all of the like really cool features and you didn't build it yourself, right? So this is one of the things I think it's a T3 Theo. I don't know if you've seen his YouTube channel. He's like a startup CTO. He's great. He has a really great following, and he just builds in the public. He has
Nice.
like a streaming platform. They're a Y Combinator startup. But one of the things is that I've learned about a lot of like the new web stack stuff through that. And I'm like teaching an old dog new tricks. I'm 40, so I've seen a lot of iterations of the internet. But it's cool when somebody who's like in the early to mid 20s who's like, oh yeah, I use this technology, use that, and I'll take some of it with a grain of salt because I've been through hype phases. But some of it, I'm like, this is better and cheaper and cooler. Like this is, like you have to pay attention to this stuff. So yeah.
Absolutely. Well, why don't we wrap up with the questions we always wrap up with? We like to start out with what are we going to do differently in our career as a result of having read this book, or I guess having read the second half of this book at this point? Nathan, where do you stand on that?
Yeah. So I'm going to take the advice on the personal and team scaling. I think the book made a solid call out on pair programming, and I think I've brought this up a couple of times. But like, I need to make time to do this at my place.
Me too.
There's a couple of problems I think we could solve in the near term that we're doing with some pipeline automation, and I think the person that I work with on this, it would be really cool to at least spend a couple of hours pairing up on this and like get through the nitty gritty stuff. And I think it would be better for both of us, both for me from like a empathy standpoint of like understanding the domain of the problem, and then also just like seeing all the stuff and working together. I think that'd be fun.
Yeah, the company I'm at is a huge proponent of pair programming, and my team isn't great about doing it. I need to be better about that. I'd like to focus more on caching. I've never really had to implement a full caching strategy for any product from start to finish. And I'm pretty good about knowing that caching is like a tool you can use. But I just want to be better about knowing the specific caching strategies you can use. And we talked about a lot of them in this book. I feel like that's great. And that's been a common theme on the podcast, right? Did we read this book and did we come away from it thinking I'm a caching expert and know everything there is to know about it? Absolutely not. But the next time I'm in a situation where we do need to look at caching, when I say, you know what, I have a book about that. I'll just read, I think it was chapter 6, right? I'll read that super quick and sort of be caught up on it. And we hope that effect is kind of trickling down to you as a listener, right? Where the next time you need to do caching, we hope that you pick up this book and read it cover to cover like we did. But if you don't, just say, I actually listened to a podcast by two very smart engineers who were discussing caching, right? And it was this book, Web Scalability for Startup Engineers by Artur Ejsmont. Let me go pick up a copy of that book and I'll give it a read because I think that would be really helpful. So yeah, I just want to keep the different kinds of caching strategies more at the front of my mind as we're building out new products. And then finally, we always like to say, who would you recommend this book to? So Nathan, who would you recommend? Web Scalability for Startup Engineers.
Yeah. So, sometimes my recommendation changes from part 1 to part 2. It's the same for this one. So founding engineers who want a deeper dive into the philosophy of the decision-making process of like which technologies to choose. I would recommend reading Fundamental Software Architecture first, just because I think it really shows you a broader scale of patterns that are a little bit more modern. But this one is really specific to startups. And I think while the software architecture book's great, there's a subset of those solutions that are actually appropriate. And I think this book does a good job of pointing those out. I also, again, recommend short form media for the person that would also recommend this book to. So to supplement, like if you want to dive in deeper, this is exactly why pragmatic engineering, Byte Go, and a bunch of YouTube exists. If you get into the caching section and finish it and go, ooh, I guarantee you there's a 20-minute YouTube video on the caching topic that you want to find out about. And that's such a good way of digging into that kind of stuff. yeah, I think it's exactly who I'd recommend it to. I don't know if it would be a broader scope. If it, I don't think it would just give it to anybody. It wouldn't be in my top 5 general engineering books. But if you're interested in startups, I definitely think that this would definitely be in the short list.
Yeah, that's about where I'm at. I mean, I think my recommendation kind of stays the same from the first episode. Are you a startup engineer who has to deal with web scalability? This is the book for you. It doesn't pretend to be a book for anyone else, right?
Right.
And I'd also recommend to people who are interested in web scalability, but not necessarily well versed in it. Again, I think if this is something you've been doing for a long, long time, you might read this book, and it might be reassuring in that you think, okay, yeah, I know this, I know that. Okay, I'm kind of calibrated correctly here. I don't know how much new stuff you'll learn from it. And again, it's a really great book. We really loved it. It is 10 years old, and it's 10 years old in a fast developing field. The principles still hold true, but every time I would read something talking about a specific technology, it was a little frustrating to have that kind of doubt of like, is this still true, or is this still the best way to do it? I feel like I'd have to do a lot more supplementary research to kind of fully solidify my understanding of the topic. So great read. I think we really enjoyed it. If you are a startup engineer who has to deal with web scalability, a fantastic comprehensive resource to give you an idea of all the different strategies you would tackle. Just because of its age, you're going to have to do some supplementary research on your own. But, that's par for the course in this industry. So I think that's where I stand. Good book, good episodes about it. We've had a blast with it, and we thank you for tuning in. We always try to make these episodes like around an hour, and then we always make them about 90 minutes because we have a great time discussing them. So if you've made it this far, then congratulations. You're a super fan. If you made it this far, what should they comment in the comments? If you're in the this far, include the word platypus in your comment. And that way we'll know that you made it to the very end of the episode. Or just email me. Email us the word platypus. We'll know that you made it to the end of the episode. And as always, you can contact us at contact@bookoverflow.io. If you're on YouTube, like, subscribe, leave a comment. All of it helps to sort of boost us in the algorithm. You can follow us on Twitter at Book Overflow Pod. I am on Twitter at Carter Morgan. Nathan is on Substack at Functionally Imperative, and you can also find his YouTube channel, Functionally Imperative, where he does interviews with interesting creators on a less regular basis than our manic schedule to read a book a week, roughly. I think that about wraps it up. Anything else we got, Nathan?
Nope, that's it. This was a lot of fun.
Well, great. We will be back next week with more books. You can always find our reading schedule on our website, bookoverflow.io. It is just an iframe of a Google Sheet, which I think is a very good decision because it means every time I want to update the book, I just have to update a cell in a Google Sheet. So yeah, check us out there if you want to follow along with the reading schedule. We've had a blast with this book. We hope you keep tuning in. Like we said, this is just the beginning, and we have some exciting things to come with the podcast. We can confidently say that we have recorded a few more interviews and we have a few more scheduled. So please stick around. Got some great bonus episodes and some great discussion episodes coming along. So thanks for tuning in. We'll see you folks later.